Okay, here is our second word problem and the last one we're going to do for right now. I'm also going to send another one as an attachment, so be sure and download that one as well, okay? All right, so we have a first number plus twice the second number is 8. Twice the first number plus the second totals 25. Find the numbers. So first let's identify, we have a first number, we have a second number. So like I said on the video, let's always let x be equal to the first number, simply because x comes before y in the alphabet. Then let's let y equal the second number. Out of habit, it just makes things a lot easier. So now let's set up our equations, okay? We say a first number, so our first number is x, plus means add, twice the second, so twice the second number, that means 2y, right? Is 8, is means equal to. So that's equation number 1. Now let's go to equation number 2. It says twice the first. So now I do 2x plus means add, the second, y, totals, total means equal to 25. So there are my two equations. Now, if I look at my two equations, do I have any signs that are already opposites of each other? You know, where one's a plus and one's a minus? Nope, sure don't. So what I'm going to have to do is I'm going to have to use my rules of least common multiple and my opposites, okay? So what do I want to get rid of? Do I want to get rid of x? Do I want to get rid of y? It doesn't matter, okay? One of these equations is going to have to be multiplied by negative something. So I'm going to choose the top equation just because 8 is smaller than 25 and I'd rather multiply by 8 to 8. So I'm going to take this equation and I'm going to multiply this equation right here by negative 2. Now you might ask, why am I multiplying by negative 2? Well, look right here. If I use negative 2, what is going to happen to my x values? When I distribute, let's use a different color. When I distribute negative 2 times x, I get negative 2x. Isn't that the opposite of positive 2x? It is. So let's do that. I'm going to say negative 2 times 2y, that gives me negative 4y, equals negative 2 times 8 gives me negative 16. So I used my least common multiple rule right here, my least common multiple rule, so that I can get rid of my x values. Now, could I have gotten rid of my y values? Yes. If I wanted to eliminate y, I would have used LCM of negative 2 as well, but I would have done the bottom equation instead of the top. So now let's write this equation exactly the way it is. I'm not changing a thing. 2x plus y is equal to 25. So now, look at what I have. My x's are going to eliminate each other. That was the whole point in what I wanted to do, okay? So let's do this. I have a negative 2x and a positive 2x. When I add those together, I get 0, which is exactly what I'm looking for. I have a negative 4y and a positive 1y, because that's my understood one right there. So that gives me negative 3y is equal to a negative 16 and a positive 25. So when I add those together, they have different signs, so you subtract and take the sign of the bigger number. So that's going to give me 9. And then when I do this, divide by the negative 3, divide by negative 3, I get y is equal to negative 3. So y is equal to negative 3. Let's write that up there. Here, I'll write that in red. Negative 3. That's my y value. So now, once you find one letter, what do? Go back to the one of the originals and plug it in and get the other one. Does it matter which one you plug it into? Absolutely not. I do not care. I'm going to use the bottom equation this time just for giggles because I always wind up using the top equation. So I'm going to use the bottom equation this time, okay? So I'm going to take my 2x plus y. Let's substitute my y value, which is going to be -3, is going to be equal to 25, okay? Now, see how you have two different signs right here? One's plus, one's minus. When you do multiplication, what sign does that give you when you have a positive times a negative? It gives you a negative, that's right. So I'm going to have 2x minus 3 equals 25. So when I get that, how am I going to get my x by itself? I'm going to move my 3 over. That's what I'm going to do. I'm going to move my 3 by addition. And that's going to give me 2x is equal to 28. And I'm going to tell you, I'm going to have that, and my last step, I'll write it in red so maybe you can see that. I'm going to write it way up here so that you can see in this little bitty spot right here. 2x is equal to 28. And I'm going to divide that by 2. And I'm going to get x is equal to 28 divided by 2 is 14. So my x value is 14. So my ordered pair is positive 14, negative 3. Now, several videos ago, when we were setting up problems like this, I told you that there's a way to check and make sure your answers are correct. Do you remember that? Substitution, that's right. So if I wanted to make sure that my answers are correct, what would I do? Here is your x value, here is your y value. You would want to take those and plug those in and see if they work. But remember, to solve a system, they have to work in both equations. It's not a, oh, it works for you, but not for you, so it's okay. So to determine if they're a solution, that means that you have to make sure it works for both equations and not just one of the two, all right? Okay, well, I hope you have enjoyed solving systems of equations with all of the methods we can use. Come back and we're going to do solving systems of inequalities next, all right? See you then.